In 2007, 205.5 million computers were disposed. That is over 112,000 computers discarded per day. 157.3 million of the 205.5 were trashed and only 48.2 million were recycled. That is only 18%. In many countries, e-waste is the fastest growing type of waste, as cheap prices mean replacing the electronics is cheaper than fixing them. The low price of devices often means low quality and a shorter lifespan. 50 million tons of e-waste is dumped into landfills worldwide every year. In Hong Kong, it is estimated that 10 to 20% of disregarded computers go to landfills. Developed countries have strict environmental protection laws. These laws exist in order to prevent environmental and health problems resulting from exposure to hazardous and toxic metals, chemicals, and toxins within the device. With the environmental laws in place and the high cost of recycling electronics, means e-waste is exported to developing nations because it is more economical and the environmental protection laws do not exist there. In the United Kingdom, 23,000 metric tons of undeclared e-waste was illegally shipped in 2003 to India, Africa, and China. In the EU, 8.7 million tons is produced yearly. 25% of this waste is accounted for. Thus, 75% of this waste is unaccounted for. 6.6 million tons of e-waste isn't recycled. These are the metals computers contain. With the chemical symbol of Cu, copper is found in the ore chalcopyrite. Chalcopyrite is found in granite, an intrusive igneous rock. With the chemical symbol of Sn, tin is found in the ore cassiterite. Cassiterite is found in granite, an intrusive igneous rock. There are two different types of igneous rocks, intrusive and extrusive. Intrusive rocks are formed underneath the Earth's surface when magma becomes trapped in small pockets. The magma then cools and solidifies underground. Intrusive igneous rocks are coarse-grained because the magma solidifies slowly beneath the Earth's surface. Physically disturbed landscapes as a result of mine workings, waste rock and tailings disposal areas, and facility development. Increase the acidity of soils. Such soils can be toxic to vegetation and a source of metals can be released into the environment. Degrade surface and groundwater quality as a result of oxidation and dissolution of metal-bearing minerals. Increase airborne dust and other emissions, such as sulfur dioxide and nitrogen oxides, from smelters that could contaminate the atmosphere and surrounding areas. To obtain cassiterite, the ore must be dredged from a pond or lake. The soil deposits in any water have a certain predisposed composition. Through dredging, this composition can be altered. Groundwater interception. Open pit mining and underground mining will cause toxins and acidic chemicals to seep into the rock, then migrating into groundwater. Fugitive dust. Dust from quarry mining or processing can pollute the air. Deforestation. Forest lodging is done in the vicinity of mines to increase the available area for storage of created debris and soil. This also disturbs the wildlife from the surrounding environment. The ore is crushed. Then it is ground in a SAG mill. The ground ore then goes through the flotation process, where the slurry is created. The slurry concentration is then melted through the smelting process. The molten concentration then goes through refining processes, such as electrolysis. Finally, the molten concentration is then cast into cakes, ingots, rods, sheets, etc. Tin mining process. Gravel deposits are brought up by dredging. The gravel deposits then pass through a series of revolving screens. The perpetrated tables then sort the soil, sand, and stones from the tin ore. The ore then goes through several concentrating processes. Limestone and sand are added to react with the impurities. Limestone and sand react with any silica or iron present in the concentrate to form slag. Tin forms compounds quickly with slag. The slag from the first furnace must be processed before discarded because it contains a lot of tin. Slag is heated in another furnace along with crude tin to remove any impurities and recover the hardened tin. Liquefaction occurs by efficiently removing any iron, arsenic, copper, and antimony that are present. The molten tin is then agitated with poles of green wood. The wood produces steam and stirs the tin concentrate. Impurities rise to the surface in the form of scum. The purity of the tin is now 99.8%. The tin concentrate can go through electrolysis if higher purity is needed. The tin is then cast into ingots, sheets, rods, etc. HEP leaching leaves behind large amounts of toxic waste laden with toxic acids and heavy metals. The waste is then placed in a dam. The dams aren't always structurally sound. They either leak or fail. The dams aren't dismantled after mine closure, remaining behind permanently, producing a long-term environmental hazard. ARD contains sulfuric acid. The pH of the water decreases once sulfide oxidation starts. Under low pH conditions, ferric sulfate must be oxidized before ferric iron, which is capable of oxidizing other minerals such as lead, copper, zinc, or cadmium sulfides. As a result, ARD frequently contains high concentrations of toxic dissolved metals that leach into groundwater and surrounding rock. Slag contains elevated concentrations of potentially toxic elements. Slag is discarded onto a rock face when it solidifies and becomes part of the environment. Toxic elements can leach into the surface under natural weathering conditions, causing pollution of soils, surface waters, and groundwater. The toxic chemicals that are used to extract the valuable metals from the ore remain in the tailings after the end of the process and may leach out into groundwater. The rock that is natural and doesn't contain the wanted mineral naturally contains dangerous chemicals such as arsenic and mercury, which leach rapidly after the rock has been ground up and exposed to wind and the rain. This is the cost production of copper and tin, primary and secondary. Several metals that computers contain are listed as hazardous by the RCRA. Disposing of computers can cause the heavy metals to leach into the surrounding ground and groundwater. This harms the organisms of the environment and the people who live in the proximity. E-waste also rots and in the process produces methane gases, which are explosive and contribute to the greenhouse effect. Toxic substances such as dioxins are produced when plastics are incinerated. Ash from the incinerator contains heavy metals and other toxins. The toxins leach into the surface and the groundwater. Black markets extract valuable metals from dismantled computers, then melt down the metals, producing air pollutants. This diseases the inhabitants of the surrounding area, causing brain retardation, cancer, and birth defects, etc. Legislations and regulations to reduce environmental impacts can be enacted and enforced. Governments can require mines to adopt increasingly effective environmental procedures and evoke penalties for failure to comply. Better regulations and better enforcement of existing regulations are keys to improving environmental performance in mining. Laws exist that prevent countries from exporting metals and e-waste to other nations and as disposal. The laws are still prohibited. E-waste and metals are sometimes disguised as donations. Recycle. Computers contain a significant amount of recoverable metals from wire and circuit boards. Construct and plan mines around existing infrastructure. Mining operations should invest in renewable energy sources instead of using diesel fuel. The extraction of fossil fuels and the construction of infrastructure required for energy production have their own environmental impacts. Mines should invest in solar power or wind turbines. Maintaining biodiversity by transplanting or cutting any endangered plants found on mining operation.